Okay, here's my 555 circuit. I'll just go to the schematic. I started off looking at if there's a way of isolating digital signals using a transformer rather than an opto-isolator. I can't think of a good reason to do this, except if you're out of opto-isolators one day and say you've got a ground loop between your PC and your hi-fi or something, and say if it's a laptop and you want to disconnect it from ground, then you could isolate the data lines, say serial lines, using a transformer instead of an opto-isolator. So I'm using a transformer here with a resistor in series, and this is just connected to a PC serial port, and it's sending data to this transformer, which causes a current to flow either one way or the other way through the primary winding of the transformer. And because this transformer is just made out of a ferrite ring off a cable, I think, just one of those ones they use to stop interference, it doesn't have much inductance, so you just get a tiny little pulse, very short duration, every time the input changes state. Now, to turn that back into steady logic levels between the changes of state, this 555 timer is used. It's actually half of a 556, but it's the same thing. So if the pulse goes positive, it triggers the top comparator and it resets the flip-flop. If the pulse goes negative, it sets the flip-flop, so that starting off with little pulses that go either positive or negative, that turns into an ordinary serial data stream. Then I guess because I had another half of the 556 left over, I kept going. So now I've got a monostable here that gets triggered off the start pulse in an RS-232 signal. So that produces a pulse that lasts for the whole character, and then I use that pulse to enable an astable, and the astable's here, so that the astable is held in reset when there's no character, and when the character starts, the reset is released, and that generates a bit clock that generates a pulse in the middle of each bit cell of the RS-232 serial waveform. Then I've got another monostable that generates a little strobe pulse just after the character's finished. So I think that's illustrated up the top here, yeah. And then I've fed the data along with the bit clock and the strobe pulse into a 4094 shift register. So that then turns the serial data into a parallel word. So it's not really a UART because it's not universal and it doesn't transmit, so I guess it's just an R. Anyway, the parallel data comes around, and I wanted to compare it with a character so that it would only respond to a certain character. And one way to do that's with a lot of XOR gates, but that would be quite big. So what I do is a cheating way. I just tie the outputs of this shift register to some pull up and pull down resistors, and whenever the code is not right, there's a bit of a bus contention there, and it draws lots of supply current. But if the code is just the same as the pull-ups and pull-downs, then there's no bus contention, and it draws almost no current because it's CMOS. So then I have a little sensing circuit with a dual NPN transistor, and that basically just, if there's any current being drawn from this circuit, it'll go into the negative supply rail through this very small resistor. It's only 33 ohms, so it hardly affects the voltage on the supply pin of the chip, but it can sense whether there's current being drawn due to a bus contention or not. And if there's a match in the code, this line goes low and triggers this 7555 timer. And I used a 7555 because I wanted to use a big resistor. So this generates about a 2-second pulse, even if the character is in the middle of a long line of text and then there's a line feed afterwards and everything. It'll pick that pulse and it'll turn it into a 2-second pulse, and it turns on this MOSFET and it turns on the motor. So I'll just try and test it. So go to IRC. I'll ask someone to test it for me.
Someone type a question mark, please.
Come on, guys. I'm getting bored. Okay, I think I have to type it myself. Okay, so it's recognized the character and turned on the motor.